Welcome to this tutorial in which we will look at the basics of scripting in C#. We'll use a factory as an analogy to explain the different terminology used for scripting like namespaces, functions, variables and data types. Once we've covered that topic, we'll look at Visual Studio and we're going to create two functions which we explained in the animation just to show you an example on how functions work and how they can be generated. But that's enough said. Let's go. Let's use a factory as a metaphor for scripting in Unity. The building blocks for scripting can be seen as the raw materials, and these normally consist of numbers and letters, and these can be processed to get some valuable information. One of the most common types are whole numbers, also known as integers. So the integer is the data type. And these numbers can be positive or negative. For more precision, a decimal point can be used, and that is called a float. And these can have up to 7 decimal places. If you want even more precision, this can be achieved with a double, and that can be a number with up to 15 decimal places. Next to numbers, we can also use letters, and these are referred to as chars. So the data type is char. Then we have booleans, and these are referred to as bool, and these are a yes or no function, or referred to as 1 and 0. These are the basic building blocks for scripting in Unity. There are more variables they can use, but we'll stick to the basic ones for now. To get useful information out of these building blocks, we need machines, and these machines are referred to as functions in scripting. With these functions, you can calculate, for example, the amount of good products leaving the system, the efficiency, or if you're more into game development, you can calculate how many enemies are left or how many items are left in inventory. To make these calculations, we use functions. In some examples, people also refer to them as methods. They are almost identical, although functions and methods are slightly different, but we'll stick to functions for the moment. The functions can be recognized as they always have two brackets, open and close, and the brackets are placed behind the name. So let's take the example that we have right here and let's calculate two numbers, and we will use two floats. So when using functions, or the machines that we refer them to, they are normally specified for one data type, and we put this in front of the function. In this case, we have a function that processes floats only, so we can only insert floats in this case. But before we insert the numbers we have defined, we need to give them a name, a unique name, so we can track them. They're both floats, and we've been giving them the names mynum1 and mynum2. Not really original, but we use those. So let's put them in the machine right here. And we want everybody to be able to use this function, so we make it public. So everybody can insert different numbers into this machine, no restrictions, and even people from other factories can use this function when they please. For the machine to operate, the inner workings of the machine, we need to add 2 additional float values with unique names, and these are only used for the internal processing of the machine. We let the machine do its work and we get the multiplication of these 2 numbers. This is a unique value, which is also a float, and we give it a unique name, in this case results. So we can track the multiplication value, and let's take a look at what we've got at the moment. We have a function, so a machine, which can be used to process floats, which everybody can use, so it's a public function. The 2 floats which are needed for the inner workings are placed between the brackets of the functions, and these are called num1 and num2. But function is not really a descriptive name, so we cannot check it once we go back into the scripting. So in this case, let's call it multiply, so we can quickly see what the function does. We may want to put this value in another machine for more processing, and therefore we want to track this value. And this is normally done through a result or a result return. So we want to put the multiplication in a next machine or use this value, which is provided in a return. In our case, we have the 35.75. So this function returns a value that we can use for further processing or other uses. Another function that we frequently see is a void function. This function doesn't return a value and is normally used to start something or check if a certain situation has happened. A standard function included in Unity is the awake function, and that function sets everything at the start of the program. So it's powering up the machine, it's turning on lights, or it's checking if a button has been clicked. These are typical functions with no return outcome, and they're just used for starting up a process. Let's head back to our machine and use the value we have in the next one. In our case, we want to take the square root of the result, and when you start scripting, it may be tempting to place all of the calculations inside of a single machine or one function, but it's not recommended to do so, as you want to separate the functions from each other to have the code as small as possible and limit all the functions to one functionality. This makes the code easier to read and understand, especially when the code gets more complicated. So we keep the multiplication function and the square root function separate from each other. Also, for this function machine, the second one, we can only insert float values. The machine is for everybody to use and uses a float called mynum3 for the inner workings. After this has been processed, we get the result and we store the result in another float which we call square root 1. So let's take a look at what we have got at the moment. We have the original float values which are stored in mynum1 and mynum2. We have a multiplication result which is also a float stored in results. And we have the square root value stored in square root 1. We can even take this a step further and build an entire factory. And for the scripting example, this is called a class. We can place various machines, or functions as we call it, in this class, and they each can process different data types. So classes, or the factories, can have different machines, different functions, all dedicated to a specific task. With different classes, we can organize the work, but also have communication going between the different classes. Inside the class, some functions can be shielded as they perform very dedicated tasks. A factory as a whole or a class as a whole can also be shielded when this is needed. In Unity, when you've not specified that something is public, it will be private by default. This takes us to the last important aspect, which are the so-called utilities. We have created different classes and different functions, but the way of working, for example, powering up, connection to the internet, or working protocols, have not been defined, and these needs to form a uniform way of working, and this is being arranged through the use of namespaces. So namespaces are a collection of classes as well that support the use of the classes we have defined and the functions we have defined through a standardized way of working, so standardized functions and organizations for have multiple people and multiple classes work together to avoid conflicts. And especially for larger projects involving multiple people and multiple classes and complicated code, this becomes increasingly important. But let's take a look at the Unity and let's see how this works. I started up Unity, started up where we left on with the last tutorial. But to create the script, I want to create a new folder inside of the assets folder to keep all my scripts together. So right-hand mouse button, create, and then select folder. I'm going to call this scripts. So everything is going to be combined. Let's enter this folder, right-hand mouse button, and now we are going to create a C# script. We're going to give it a name. This is the class name or the factory name, and all of our functions are going to be inside. We are going to do calculations, so let me just call this calculations. And there we have it. You can see the script already on the right hand side. It's reloading, and if you double click on it, it will open it up in Visual Studio. Let me just bring this in. So it's opening up on my other screen, and this is the basic script. Let me just make this a little bit larger so we can see what is happening. And this is the basic script that Unity starts up with. When we take a look at the top, we see the 3 namespaces right here listed. 2 of them, the top ones, are for Microsoft. The bottom one is for Unity Engine directly. And what this allows us to do, for example, the void start and the void update are part of the Unity engine namespace. That makes sure that each of these functions is started up in the same way. So each of the classes that we define, so all the different scripts that we have the same method of starting up and evaluating if something has happened. The update function will check each and every frame if an occurrence has happened. For example, I want to check if a player has hit something or an object inside a machine has touched something. It will check each and every frame. If I have 24 frames a second, it will check 24 times a second if something has happened. So this is done inside of the update function, and this is executed always the same way because I'm using the Unity engine namespace. Also, I have a bunch of options available. For example, mathf, which is the mathematical operation. And you can see here, I have a list of options available. So I can calculate the square root, for example, or all these different functions using the namespace. And that's going to be executed always in the same way. But let's take a look at the scripting first. So we have the namespaces on the top. Then we have a public class. So we call this a factory, and this factory is called calculations. So it's going to do the calculations for us. And it's always going to derive from mono behavior. Mono behavior is also a namespace. It's part of Unity engine, but it's a special one as this takes care of the start and update function. So it's going to make sure that each time we start the program, Unity is going to look at the scripting attached to a GameObject and make sure each and every one of these scripts is going to be executed exactly in the same way, so we get no conflicts there. The scripting itself takes place between those curly brackets. So we start with an opening bracket and we close this one. So everything between here is the scripting, and we have two functions in between. So the start function, as we can see, it returns nothing. It just starts up, so it's a void. Starts with a capital letter, and we see the two brackets here. Then everything placed between those brackets is going to be executed. It is common to indent your code. So if you write some code, as we see in a second, to indent it to make it more readable for other people. Also for the update function, it doesn't return anything. It just looks at each and every individual frame if an occurrence has happened. It doesn't give us back any values, which we do need for our calculation functions. Let's create our first function. We have the two variables, which are the floats, and these are normally placed on top of the script. So we have a float value, and we call this mynum, actually mynum1, and we gave it a value, so we make it equal to 5. In this case, it's a float, so I type $F. Then we use a semicolon to end this line, and we have another float. And this is mynum2, and that's equal to 715, and that's a float. And then again, we end with a semicolon, so that has been applied. So we have the two numbers. Now let's write the function, or the machine as we call it. We call this multiply. So we have multiply, and then we put in the two round brackets or parentheses, depending which type you like. Then we are going to insert a float value, so we'll put that in front. So we have a float, and we want to make this function available to everybody. So we're going to put in public. So we have a public float multiply. And for the inner workings of this function, we need two variables. And this is more of a template, so we can write anything we like, but we need a float to go in. And we call this num1. Then a comma, and we want the second one, which is a float, and this we call this num2. But we can give it any value that we like. We only use this for the inner workings of this function. So we're going to have two curly brackets, and then we're going to do our math. So let me just scroll down, and we're going to say it's num1 multiplied by num2. And we need to store this inside another variable, and we call this result. So we make the result equal to the multiplication of num1 and num2. And what we then want to do is we end this first by a semicolon. We want to return this value, which is the result, and we're going to end it And the reason it gives this red underline and gives me a long description is that we have not defined the result. So we need to go up here. We need to set or tell the software we have another variable, which is a float. And in this case, it's a result. And we're gonna end it. And in this case, you see that the wavy red underline is gone. And now we got to return the result. So we got our script ready. If we were to start the program in Unity, nothing would happen, as Unity would not look inside of the scripting folder. It will check, however, all the components, the game objects on the left-hand side. So what we can do is we can take our script and drop it onto, for example, the cube. And if we were to select the cube, we see all the components on the right-hand side. And we do see our script. That's going to be executed, but we have not told the script to execute it at the startup, so it's never really started. So let's head back to the scripting. You see that the function is located here. We want to head up to the start function, and we want this script to be executed upon startup. So what we can do is we can say multiply, and we can execute it. And we need to end this with a semicolon. But we need to put something in there, and these are the values that we defined at the startup. So we're gonna insert this one, we put a comma, and we want the second one, and we're gonna place that one here. And now the script is going to be executed. So what is happening is that I have defined two numbers, 5 and 7.15. Those are going to be put inside of the multiply function, which is located here. So 1 and 2 are inserted into this function, and then the machine is going to operate. It's going to use for internal workings num1 and num2. It's going to do the multiplication, it's going to return the result, and the result is going to be inside of multiply. We can execute the script, but really want to see it. And to show this inside of the console in Unity, we can say print, but in Unity this is called debug.log. And this is part of the namespace. And then we can say, for example, this is the multiply value. And this is only text. And then we can say, show me please the result. And we're going to end this with a semicolon. So everything is ready. So we're going to save this one. We're going to head back to Unity. It's going to update everything. So we got the script attached to the cube, as you can see here. At the startup, we're going to say execute the script and show me the number. So we're going to start the program, head over to the console, and as you can see, this is the multiply value and it's 35.75. So that seems to work well. Let's head back to the script and execute the square root calculation. So we're back in Unity, and let's write the function to take the square root of the result. So we got the num1 and num2, we store that value in the result, and then we return the result in the start function, and then we got this result. Then we're going to write this function, and let's call this square root. And we need the parentheses behind it. It needs to take a float, and we can call it anything we like. We take a num9. This is only for the inner workings of the function. We want a float to go in. And we want this function to be public so everybody can use it. That's the basis. Then we got the curly braces, and that's actually our script. And what we want is we want to take the square root, which is a function mathf. And if I type the dot, I get all the options available that I can use. And square root is all the way on the bottom. And I want the square root taken from the result. And then we're going to close it with a semicolon. But we need to store this value in a variable, but it needs to be calculated. So let's call this square root node1, and that's equal to the result that we have. And what we then want is we want this to return to us. So please return to me square root 1 and close this. So everything is set up. The only thing that we have not defined yet is the variable square root 1. It's unknown to the scripting, so let's just give it a placeholder on the top. So we're going to define a float, and we want the square root 1 to be a placeholder for this value. Now all the red lines are gone, as I have defined this float value as well. And let me just copy this here. I'm just going to reuse it. So upon startup, I want you to start the function SquareRoot. And I want you to take result, not num1, not num2, but the result. And I want you, this is the square root value, and I'm gonna say this square root value. And then I want you to show me square root naught 1. This is the value I want to see. So what is happening is I have the variables 5 and 7. Those are going to be multiplied, stored in the result. The result is going to be put into the square root function, and that result is going to be put in the square root. Therefore, I have square root here at the startup function, and I have the result at the startup function. So if we save this, we can head back to Unity. It's recalculating all the scripting. And if I start the program right now, you can see on the bottom, I got the 3575, which is the multiplication value. And we got the square root value, which is 5.97. So that seems to work fine, and that's the basic for the functions, but we can take it a little bit further. If we head back to the script, we see everything is set to private here, but I would say public, for example, the public and here as well. So I make these variables public as well, and let me just save it. And if I head back to Unity right now, you can see that on the right hand side, the values mynum1 and mynum2 become available to me, and I can change these to what I like. So for example, I can change these to 10, and then it's going to execute the same scripting but with these new values. And as you can see, my multiplication value is now 50 and my square root value is 7. And there you see that this is the power of the public availability of the variables, and I can make these changes also by communicating between the scripts. This is obviously a very basic way of presenting variables and a script. Normally you can optimize it further, so you can use less code to get the same result, but the logic behind it is the same, and this is what I wanted to demonstrate. As soon as you understand the logic behind it, getting code from the internet or from tutorials or even ChatGPT, it's much easier to understand where to place it and how to use it. So that concludes this tutorial. See you with the next one.